Mental well-being is a silent pandemic. According to the WHO, depression and anxiety cost the global economy over $1 trillion every year. It's time to make a difference. Learn how to enhance your lives through a masterclass from Founders Wellbeing and my good friend Sandeep Rao on mental wellness. Visit founderswellbeing.com/masterclass to enroll and enter TLJ20 for a 20% discount. Be a better version of yourself and make an impact. Devternity is the top international software development conference with an emphasis on coding, architecture, and tech leadership skills. The lineup for this year is truly stellar and features many legends in software development. Names such as Robert Uncle Bob Martin, Ken Beck, Scott Hanselman, Venkat Subramaniam, Kevlin Henney, Alan Holub, Mary Poppendick, and many other prominent names, including some of those who have also appeared in this podcast before. The conference takes place online, so you can enjoy it from the comfort of your couch. We spoke to the Devternity organizers, and I'm happy to share that TechLead Journal has got the 10% discount code for you. Enter the promo code AWSM_TLJ when you purchase the ticket on devternity.com. Here's the promo code one more time, AWSM_TLJ. Depending on the time when you purchase the ticket, early price is still available. See you there.
The companies that are most successful getting the most out of the cloud, that are building amazing things. You think about Uber, Spotify, they embrace the fact that this distributed application architecture is now a first-class thing that we can incorporate into our applications. You don't get there by treating the cloud as a collection of virtual machines. You get there by really thinking about these application patterns.
Hey everyone, my name is Henry Suryawirawan, and you're listening to the TechLead Journal podcast, the show where I'll be bringing you the greatest technical leaders, practitioners, and thought leaders in the industry to discuss about their journey, ideas, and practices that we all can learn and apply to build a highly performing technical team and to make an impact in your personal work. So let's dive into our journal. Hello my friends and my listeners, welcome to the TechLead Journal podcast, the show where you can learn about technical leadership and excellence from my conversations with great thought leaders in the tech industry. If this is your first time listening to TechLead Journal, subscribe and follow the show on your podcast app and on LinkedIn, Twitter, and Instagram. And if you'd like to support my journey creating this podcast, subscribe as a patron at techleadjournal.dev/patron. My guest for today's episode is Joe Duffy. Joe is the co-founder and CEO of Pulumi. If you haven't heard about Pulumi, it is a universal infrastructure as code SDK and platform to deliver infrastructure with high velocity and scale through software engineering. In this episode, we discussed cloud engineering concept and how Pulumi is helping to shape its future. Joe started by sharing his story founding Pulumi and the evolution of the cloud adoption. He shared his view on why cloud should be a first-class application architecture concern and the concept of cloud as an operating system. Joe then shared in depth the concept of cloud engineering as the next evolution of DevOps and explained how it changes the way we build, deploy, and manage infrastructure and application in the product development lifecycle. Towards the end, Joe shared his view on the future of cloud engineering and how Pulumi is helping organizations adopt cloud engineering at scale. I hope you enjoy my conversation with Joe. If you do, please help share it with your friends and colleagues who can also benefit from listening to this episode. My ultimate mission is to spread this podcast to more listeners, and I really appreciate your support in any way towards fulfilling my mission. Before we continue to the conversation, let's hear some words from our sponsors. The ISA-QB Software Architecture Gathering is the international conference highlight for all those working on solution structures in IT projects, primarily software architects, developers, and professionals in quality assurance, but also system analysts who want to communicate better with their developers. A selection of well-known international speakers will share their practical knowledge on the most important topics in the state-of-the-art software architecture. The conference takes place online from November 14 to 17, and we have a 15% discount code for you. Enter TLJ_MP_15 for 15% discount. Today's episode is proudly sponsored by Skills Matter, the global community and events platform with more than 100,000 software professionals. Here, members can organize their learning experiences around the technology topics they care about most. You get on-demand access to their latest content, thought leadership insights, as well as the exciting schedule of tech events running across all time zones. So whether DevOps or data science is your buzz, or you're a fan of functional programming or all things cloud, you can make real connections with people who share your interests. Head on over to skillsmatter.com to become part of the tech community that matters most to you. It's free to join, and you will find it easy to keep up with the latest tech trends. Hello everyone, welcome back to another new episode of the Tech Lead Journal. Today I have with me someone named Joe Duffy. He's the founder of Pulumi. So if you haven't heard about Pulumi, it's one of the infrastructure as code tools which tries to solve how to create infrastructure through code or software. In this case, later on we will discuss about it. So Pulumi is just one of many options available out there. Today we'll be talking a lot about cloud engineering and infrastructure as code and things related to that. So Joe, really looking forward for this conversation. Thank you so much for your time today.
Yeah, likewise. Thanks for having me, Henry.
Joe, I always like to start my conversation with my guests by asking them to share about their career journey, any kind of highlights or turning points in your career.
Yeah, it's a great question. I sort of break my career maybe into three phases. Very early on, I got the love of coding in my system when I was a teenager. And that was right around the time the internet was starting. The first turning point was probably, I decided to start my own consulting business to help companies with the transition to the internet. That actually planted the seed for eventually starting a larger company. Consulting business, you have to be jack of all trades. You have to do a little bit of sales, a little bit of marketing, a little bit of product engineering, a bit of support. It really taught me a lot of good lessons there. Second phase, I went to Microsoft, and that was a really formative time in my career. That was when I really saw innovation at the scale of Microsoft, and got to work on a lot of cool technologies, products, met some of the most brilliant engineers I've ever worked with in my career, probably ever will work with, and got to move into leadership positions and manage large teams at scale and really see what that looks like. And then at the end of that, I helped open source .NET and take it cross-platform. And that really reconnected me with my roots, sort of in the open source community. And then the third phase was, I decided to leave Microsoft after 14 years or so and start a company, not just a consulting business, but actually a product company, and build that and scale it. And that's been a great 5 years. So I'm the CEO of the company. In the early days, I was writing all the code in my basement, and then we're now around 100 employees. So it's been a great learning experience and a great journey.
Thanks for sharing that. So I was interested when you say innovation at scale. So maybe for people who are interested as well, what do you mean by seeing firsthand how innovation is done at scale?
Very good question. Because that's the thing that kept me at Microsoft for so long. I was always learning, always seeing new approaches to solving problems, getting new opportunities, working on different technologies. The amazing thing at the scale of Microsoft is they have many, many technologies and many products. Some of them make a lot of money. Some of them don't make any money whatsoever. Some of them are bets on the future. Some of them are more tactical solutions to address shortcomings in the market. You also have the Microsoft research arm, where you've got a ton of really smart people trying to live out 10 years into the future. And then a lot of folks trying to figure out, okay, let's take some of those ideas and incorporate them into the products. I worked on engineering teams of 5 people, engineering teams of 500 people, and everywhere in between. And so you kind of learn a lot of lessons. Like the things that work for very small teams or very early stage technologies may not be the same tactics you use for later stage technologies. Like in the early days, you're still trying to figure things out. You're willing to take more risk. You're willing to do things that don't scale. As you become much more of a mature product, those dynamics change. And so it's really fun at Microsoft. You get to see the entire landscape. Sometimes the joke, Microsoft is sort of like 250 startups at one company. And that always kept it exciting.
Right. And you spend your time there for about 14 years, you mentioned, right? That's pretty long. I think it's just another interesting thing that I pick up. So what made you decide to start entrepreneurship? Because 14 years in one company, good companies like Microsoft as well. So what made you start entrepreneurship, going into like open source routes that you mentioned? Maybe something interesting to share here.
It is a very good question. I think when I started that consulting company early on, I knew that there was more to business than just writing code or just building technologies. Although that's sort of the thing I initially gravitated towards because, writing code, it's great. You can just like sit down and make something out of nothing. But I always knew that I wanted to get back to more end-to-end business. And I think a combination of a few things at a large company like Microsoft, despite all the things that I said are great about it, it's sometimes hard to really understand, am I having a business impact? It's sometimes hard to be even in the room where critical business decisions get made, especially if you're working on a product team. I got reasonably senior over that period of time. I always felt I was still 1 to 2 levels removed. Like, unless I was in Satya, the CTO's staff meetings, I didn't feel like I was really going to have the level of impact that I was looking for. And literally every year that I worked there, I asked myself, is this the year to leave and start a company? I don't think you start companies just to start a company. You really need to have the right opportunity. You really need to be passionate, excited about going and making some sort of change in the world. And so finally, stars aligned. But the thing is, the whole time I was there, I was still reading business books, reading SEC filings, very nerdy things to do, but really staying on top of the entrepreneurship seed that was planted very early on.
Very interesting, which brought you into founding Pulumi, right? Why Pulumi? What kind of trends do you see back then? Maybe it's also a good segue up to our actual conversation later on about the cloud and the evolution and things like that. And why Pulumi?
I think Pulumi is an interesting opportunity to really reshape how people build cloud software in a more fundamental way. Just before leaving, I was managing all the languages groups at Microsoft and helping with open sourcing .NET. I really lived and breathed developer productivity on a daily basis. And what struck me is the cloud was still sort of treated like an afterthought. It was very similar to in the 2000s or even earlier than that, where people racked and stacked servers. You wrote simple 3-tier applications, didn't really think about the infrastructure. It was always the infrastructure team dealing with that. And meanwhile, the infrastructure teams I talked to, they were kind of like, hey, nobody's given us the sort of developer love that people have spent for application development, great IDEs, test frameworks, powerful languages. And so with Pulumi, the idea is the cloud's not an afterthought anymore. And all developers are building cloud software because the cloud is basically powering all of the modern software that we see today. Now seemed like a great time to say, we'll bring the cloud closer to developers, but also give infrastructure teams amazing technology and really help them be more productive and bring more joy to their lives, similar with developer productivity over the last few decades.
Yeah, you bring up a very interesting point that when we started with the cloud, right? Yeah, I mean, maybe some people, especially some traditional companies, will think of it, yeah, it's just like another data center, right? So instead of us, maybe some people managing data center for us, we outsource it to the cloud and it's just like another infrastructure. So this kind of evolution, I think, is something very interesting. I see it myself as well, where previously it's like when people call DevOps, right? So it's like dev and ops, different silos. These days, there are some movements to bring them together. And yes, infrastructure tools has always been something very unique, I would say. There are some innovations there about introducing software, but cloud brings the whole game into totally different level. You can program many things right on the cloud. You mentioned in one of your blog that cloud is actually now a first-class application architecture concern. So tell us more about this term, first-class application architecture concern.
Yeah, so another part of my background in the 2000s, I worked on multi-core and parallel programming and bringing async into all these languages. So now you have async await. Back then, we didn't have that. So we created a task framework in .NET. And this honestly led to async await in .NET. Now you see that in every language, right? This concept. But nobody had done a similar thing for cloud. I actually worked on a distributed operating system while I was at Microsoft. And this was before containers. But it was really about how do we build large scale distributed applications? How do we configure them? How do these different services talk to each other? And funny enough, that was like 10 years before we founded Pulumi. And a lot of the same patterns recur where if you take a step back, we're really in the cloud, we're building distributed applications. It's now finally, we've been talking about it in research for 50 plus years. We're finally at the age of distributed programming. And the companies that are most successful getting the most out of the cloud that are building amazing things. You think about Uber, Spotify, AWS themselves, they embrace the fact that this distributed application architecture is now a first-class thing that we can incorporate into our applications. You don't get there by treating the cloud as a collection of virtual machines. You get there by really thinking about these application patterns. And that's what I meant by that. How do we connect these different systems? How do they speak to each other? Back in the early days, we called that service discovery. We had enterprise service buses and like all this stuff with J2EE. It's like very similar patterns, just sort of cast in a new light.
Yeah. And the follow-up thing that you mentioned, which I found very interesting in your blog, you mentioned with all these distributed apps coming, cloud with its own technologies, not just providing infrastructure, CPU, memory, and all that, but also more new products, things like containers, serverless, and things like that. You mentioned that now cloud has become like a giant supercomputer. So maybe it's interesting to dig deeper here. Why do you think cloud is a giant supercomputer? How do you get the analogy from?
Yeah, the funny thing is you think about what is an operating system and you think about how do you interact with your operating system in typical programming models. Think about back in the day with C and C++, you're programming directly to the operating system's API. And then over time, we came up with Node.js and Ruby and more productive ways of programming, and they sort of abstract away a little bit of the operating system. But really, the operating system is all about controlling access to hardware and scheduling operations against that hardware. That's the job of an operating system. Well, what is the role of the cloud? The role of the cloud is it's a piece of software that manages a lot of different hardware and controls access to it and schedules access against it. And so if you use that analogy, we're sort of missing that Node.js of the cloud. We're missing these higher level abstractions. In fact, we're sort of still in the days of C, maybe even assembly, but let's give a little bit of benefit of the doubt. It's more like C, but what are those higher level programming model concepts that we're sort of missing today? And I think a lot of folks talk about Kubernetes. I think of Kubernetes as it's really just the kernel scheduler or the thread scheduler for the cloud, but it doesn't stop there. There's so much more to be built on top of that foundation. The exciting thing is we've now at least agreed on some of the foundational pieces like, hey, Kubernetes is probably here to stay. And we know how to schedule containers. And so now we can build these higher level services. Although Pulumi lays this great programmable foundation, I think the next phase is what are these higher level experiences that have yet to be built?
When you mentioned Kubernetes, I mean, it all started for scheduling like containers and things like that. While in the cloud, there are still so many other things like the VMs, the serverless, the databases and things like that. So yeah, there's a little bit of mismatch, although people are trying to Kubernetesify everything, I guess.
Right.
That's the term. Yeah. So we'll talk about that later as well. But yeah, you mentioned about this giant operating system, right? It's like cloud is an operating system where you have so many infrastructure, these hardwares that you can use, and you have to build some kind of layers to control all of them. Which brings back to the next topic, which is the cloud engineering. So with all these needs, all these resources available, you mentioned that there is probably more things that we can do in order to help people to build on top of the cloud. And you mentioned this term called cloud engineering. Why is cloud is another kind of like discipline within engineering? What is cloud engineering? Maybe you can tell us more about that.
Yeah, I think we're starting to see this term used a lot more broadly. But to us, cloud engineering is a few things. One, bringing the cloud closer to application developers so that cloud is part of the software engineering process. Two, bringing software engineering tools and techniques to infrastructure teams to help tame some of the complexity of the modern cloud. And really, all this ties into what we were just talking about, which is how do you program the supercomputer? Well, you do it with software engineering techniques. We don't think of it as an afterthought or something that is lots of copy and paste. We think that really bringing to bear all the decades of improvements in software engineering applies just as much to the cloud as it does to regular application development on classic operating systems. And then by doing the first two things, we do the third thing, which is really help break down the barrier between developers and infrastructure teams so we can just collaborate on equal footing to just build great software together. And to us, that's cloud engineering. You can think of it as the evolution of what comes after DevOps. In many ways, DevOps was more about bringing some dev techniques to ops teams, but not as much the opposite, which is really having developers thinking about the cloud as part of the application architecture. And I think you need to do both in order for that cross-pollination to happen. At least that's what we're seeing.
So it's very interesting that you mentioned this is like the next phase of DevOps, or maybe it's just another flavor of DevOps, right? DevOps itself is like, people say it's mindset, culture, where developers and operations people work together very closely. It could be borrowing each other's techniques. But I think cloud engineering maybe is like a special flavor of the DevOps or the next stage of DevOps, where you use the power of the cloud to bring the devs and the ops closer together. And you mentioned that aspects like infrastructure, application development, and also compliance here as well, how you can actually bring them together with the same engineering practices and tools. Tell us more about this aspect of practices and tools. What do they need to borrow from each other, maybe?
Yeah, it's a good question. It's very important that we don't lose some of the benefits of the prior model in this transition. I think I went through an interesting transition at Microsoft, which was, we used to have software engineers and software test engineers, and they were completely separate organizations. What you had was developers would write code, they throw it over the wall, the test organization would pick it up, test it, find all the bugs, ship the bug reports back. And it was a very inefficient way of dealing with it. And we moved away from that over time, which, most of the world has moved away from that model for good reason, because you want everybody to think about quality as a first class thing. We merged the teams, but we made several mistakes when we did that, which was we didn't recognize the importance of preserving those unique skill sets for people that really love testing. They think very creatively about how to find bugs and put in place proactive automation. I look at this sort of transition, we need to make sure the same thing doesn't happen, which is infrastructure is a specialty. Not every developer is going to want to learn how to properly configure a multi-region Kubernetes cluster that has high availability and is cost efficient and all the secure network concepts there as well. So we need to preserve all of those domain experts, but we need to combine that with the ability to use software to tame complexity at scale. And so I think it's sort of marrying the two, but not losing what makes each of them important.
Yeah, so you brought up a very good point here because people are thinking, how should they form their teams? Some people call it team topologist topic this day. You mentioned in Microsoft, you had the experience of merging software developer and software test engineer, right? Do you think also these days people should form a team where so-called the infra related people, like the administrators or maybe the operations or maybe SRE, some people call it, should they be merged with the same team and becomes like an independent product teams?
I think the answer depends a lot on the size of the team or the business. I think it also depends on the DNA of the current team. Some of these changes, you can't just wave a wand and make it overnight, even if that's where you eventually want to get to at the end of the day. But what we often see is specialization is a good thing. And at scale, you need to specialize. Like if you have one SRE, well, maybe it's okay for that SRE to be embedded within the engineering team. And maybe you want to spread a lot more of the responsibility. If you have 50 SREs, like Google, well, I'm sure Google has 500 or 5,000 or something like that, but you're probably going to have a dedicated team because it makes sense to centralize some of that expertise. And I think you'll find models everywhere in between. A very common model we see within our customers, and this is mid-scale, large scale, is the platform team. So the platform engineering team is typically a team that's in between the developers and the sysadmins, operators, and folks that are spending all their time on infrastructure. The platform team typically does take a software engineering mindset, but it's a hybrid of engineering expertise and infrastructure expertise. And their goal is to build the automation for the organization around them to make everybody productive so they can ship code faster, but also do it securely within compliance, within budget, and that sort of thing. So this has honestly been an emerging trend over the last 5 years, and it's just really accelerated.
So let's move back to the so-called the life cycle of people building products. You mentioned in cloud engineering, you have this kind of workflows, right? A very simple and common workflow, which is build, deploy, and manage. So with this cloud engineering discipline, how maybe can we do it differently in each of these life cycle? Maybe let's start from build, which is building the software itself, writing the code, maybe building the packages and things like that. How does cloud engineering do things differently?
Yeah, I think there's some micro steps in between too. So, designing, building, securing, testing, deploy, monitoring, manage. But those are the three key ones in there. I think when we approached the space, I'll be honest, when we first started, we just wanted to solve problems. We didn't say, let's go create an infrastructure as code tool. We sat down to solve the problem. And the problem to us was, honestly, building modern cloud applications was not so great at the time. I mean, you wanted to stand up just a simple containerized service that was 5 boxes on the whiteboard. Next thing you know, you're like knee deep in 4,000 lines of YAML. And that didn't feel great, especially coming from a developer experience background. And so what we did that's different from most tools is we let you bring your favorite language to express your infrastructure as code. By doing that, we tapped into the ecosystems around these languages. IDEs, test frameworks, package managers, the ability to share and reuse common patterns, and really give a great developer experience. Went from a world of copy and pasting YAML all over the place where if you had a typo, you didn't find out until 30 minutes into your deployment, to suddenly you're in your IDE typing, you're getting red squiggles and the compiler is helping you. It's just an easily 10 times better experience than where most folks are coming from. In fact, Since we launched Pulumi, we've had a number of kind of projects, I think, inspired by Pulumi come out from AWS, from HashiCorp that apply similar techniques. That was the first sort of aha moment we had that told us we were onto something.
So this might bring us to the debate, like some people like YAML, some people don't. Why do you think it's important for us to be able to do this infrastructure related thing, not just in YAML or maybe other types of configs like JSON, into something that is more general purpose programming language, things like JavaScript, Node.js, or something like that?
Obviously, we have opinions, but we want the right tool for the right job. And sometimes YAML or JSON is a perfectly fine tool for the job at hand. So we actually support YAML now as a language. Pulumi is a multi-language platform. I think the insight we had was, how do we get all of the rigor of infrastructure as code, being able to preview before deployment, getting full audit history of who changed what and when, all of these elements that we love about infrastructure as code, but take those, but then also give you your choice of language. And so for the simple cases where literally 10 lines of YAML just does the job, or maybe you're machine generating the code, in which case machine generating YAML is much easier. But we look out in the world and people are putting Go templates inside their YAML. They're writing Python transpilers so they can generate their YAML. We have domain specific languages, for like HCL, for example, that's adding sort of quasi for loops and stuff in that, but it's not a real for loop. We're not trying to bend and twist templating languages into something they were never designed to do. But for the things they're designed to do, we absolutely want to support.
Yeah, it's interesting. So for people also, when they look at all this infrastructure as code tool in the beginning, when they see a few lines of YAMLs and some configs, and boom, you can just run some infrastructure. That looks really cool. I mean, back then, wow, I didn't know that you can actually do that. People start using that. And obviously over the time, there are some constraints that you hit, right? So things like, for example, this conditional or maybe for loops. And that's why people start to customize their DSL to become further DSLs. So I find it a struggle also during that time, especially you mentioned about the broader ecosystem. You mentioned things about IDE. I think last time in the beginning, it's just text editor probably. That's the best that we could do. You don't have like autocomplete, you don't have type safety and things like that. And also things like testing framework. I think it was clunky back then when I used all this infrastructure as code. So tell us more why all this ecosystem is actually very important. It should be a first-class concern for doing infrastructure as code or maybe cloud engineering as well.
To your point, it starts simple, but it gets complex very quickly. And I think we invented programming languages to help with complexity as we scale. And I think scalability is something we talk about a lot. Our CTO, Luke, actually helped start the TypeScript project at Microsoft. And the funny thing, I went back and I was looking at their first homepage back when they launched, and it was JavaScript that scales. And I think Pulumi really is infrastructure as code that scales. And the reason it scales is because of the languages. And languages give you the ability to encapsulate complexity where it's not needed, abstract away concepts into higher level concepts so we can build bigger things out of smaller things. We would have never gotten to where we did on the application development side if we didn't have these facilities. And now the ability to apply this on the infrastructure side is very powerful. To your point, the simple things get complicated. You just look at Amazon has a virtual private cloud. Pretty much every customer that's going to go to production in Amazon is presumably going to want to spin up a VPC. They have a standard blueprint that captures best practices. Well, that standard blueprint is 4,000 lines of YAML and 6,000 lines of JSON, simply because you have all the curly braces on top of the YAML. And nobody can understand that. The reason why it's so complicated is it doesn't have for loops. And so for every availability zone, you have to copy and paste and then rename the thing from 1 to 2, 2 to 3. That same thing ported to Pulumi in Python is 200 lines of Python. Not only that, but you can stick it in a package and now give somebody a one-line way to spin up a properly configured VPC. And given that everybody in the world has to do that, just imagine worldwide how many human hours that's going to save just being able to do that. So that's just one example, but that's very, very common in infrastructure as code.
Yeah, talking about reusability, right? So in software, the concept is like we want to be able to reuse as much as possible. And then, yeah, when you start having all these so-called codified best practices, like you mentioned, best practices of AWS to create VPC. I guess when you have these best practices, then you start to see more complexity, maybe more parameters as well being introduced. And that's why all this maybe kind of like breaks the analogy. And lastly, it's about the module itself. So I think with the programming languages this day, you have good package manager. So I think like NPM, maybe pip in Python and things like that. So yeah, I think that really resonates as well with many people, I believe, with all the struggles of coming up with the best practices of building infrastructure. Let's move on to the next workflow, which is deploy. Tell us how cloud engineering does things differently.
Yeah, I think really moving to a code-centric model for how you do deployments is definitely key to cloud engineering and something we see a lot of our customers wanting to do, but struggling to do. What I mean by that is most people are triggering deployments of their applications through Git workflows today. Some are still doing them manually, but regardless, all the code is in source control. I can't tell you the last time I met an engineering team who wasn't using source control, thankfully. And so moving to that model for all your infrastructure changes as well, that's pretty much table stakes. Most people are there today, but people are struggling to actually how to trigger the deployments. The more modern cloud architectures, the line gets a little bit blurry. Let's take a serverless application. I've got an API gateway, 10 functions, and a Dynamo database or something. It's deployed in AWS. Well, if I want to add a route to my application gateway or my API gateway, is that an infrastructure change or an application change? Usually, if I have an Express.js app, I just go change routes.js and stick in a new route and I've got a new route. Well, with API Gateway, now I have to go change the infrastructure. What about the functions? If my function starts running out of memory for some reason because my application workload increased, do I have to go make an infrastructure change or is that application? So like the line becomes blurry for a lot of the infrastructure. And many of our customers want to enable developers to self-serve with guardrails. They want to make sure that developers don't shoot themselves in the foot from a security standpoint. But like some of these changes you want to enable, and building and publishing containers, another good example. And so the D in CI/CD is deployment. We think of that as not just application changes, but infrastructure changes as well. That's a key thing that a lot of people are trying to get to, and a lot of people are struggling to get there. And then once you have that, you want to do verification with testing and security and everything just built into how you're doing deployment. Same thing for application, same thing for infrastructure. So if you're detecting a theme, it's that we don't need to bifurcate how our entire team operates between apps and infrastructure. We can really share a lot of the same engineering practices.
Yeah, so I was also looking back at my previous experience, right? Like building all this CI/CD tool and introducing infrastructure as code. And yeah, it seems like there's a mismatch. So it's like a tool lifecycle thing, right? You build, package your software, you deploy maybe using software way of doing things. While on the infrastructure, it's like another set of tools. And the glue in between most likely is like bash script or some kind of scripting in between, right? Especially if you deploy your application as a container, you also have Kubernetes manifest, for example, and you have another set of tools. Most likely it's like kubectl. So I can see why totally sometimes this mismatch, this gap is actually a struggle for teams because they have two different skill sets that they need to think about. And if we do it in a programming language way, maybe it's kind of like similar. It's just like same build tools, I guess, same way of deploying, I guess. So I can see totally the advantage of using this cloud engineering technique. But I also have interest when I look at your website about this deploy lifecycle is that we can now do more advanced deployment automation. So things like maybe canary rollout, A/B testing and things like that. How does this new way actually help for this advanced automation?
Yeah, we definitely see a lot of advanced use cases amongst pretty standard workflows in our customers. For example, one of our customers has 100 production regions that they deploy into, or 100 environments, let's say. And they want to orchestrate that over the course of 2 weeks because they want to roll out to one region, make sure things are okay, start with a canary, ratchet that up to 100%, monitor all the metrics, and only graduate between environments as things are healthy, and then automate the rollback if things start to go south. Honestly, I will say what we've got is great because you can build anything you can dream of. We have something called the automation API, which is effectively what if infrastructure as code was just a library that you could program against instead of being a CLI that a human had to run or that you stuck into CI/CD. Our customers build amazing things with those self-serve portals, these advanced deployment models, custom CLIs. There's a lot you can do with it. But I'll say the current CI/CD systems, we took an approach of integrating with them. So Spinnaker, GitHub Actions, GitLab Pipelines, Jenkins, like all the standard ones we integrate with. But CI/CD systems today are not great for infrastructure. They work, but like, as you say, there's something missing there. The major missing piece is most CI/CD systems think of the world as in like 10, 30 minute, or worst case, 1 hour bite-sized chunks. many infrastructure activities can span, like I said, days, weeks. Sometimes they have manual approval steps because somebody needs to sign off on budget or provision something via a ServiceNow ticket. So it is more complicated. And so having that ability to just customize and extend the system with the automation API is a pretty killer scenario for a lot of our customers.
And some people also these days adopt this thing called GitOps, right? Is that something a different way that you have to support as well? Tell us more about this GitOps. Is it the best practice also, in your opinion, for cloud engineering?
We see a lot of folks doing GitOps, mainly because they want to be able to do a deployment based on Git branch merges and pushes. And it fits in nicely with a lot of the application lifecycle. You can basically just use pull requests as approval and review, just like you would a code review for application code changes. So it does go nicely hand in hand with infrastructure as code. I will say some people use the term GitOps to really mean Kubernetes-centric deployments. And to me, that's a completely orthogonal dimension that I have many, many thoughts on. But to me, that's separate from the notion that, hey, we're just going to do all of our deployments triggered off Git events. To me, that can be done regardless of whether Kubernetes is in the picture or not.
Right. Let's move on to the next lifecycle, which is manage. So after you build your application and infrastructure code, for example, you deploy it and the application starts running, the infra has been provisioned. So tell us the importance of this managed lifecycle.
Yeah, so a lot of folks who we talk to, it's sort of like finding a needle in the haystack when they want to find what's running in production, who did a deployment, why did something change, is it secure, how do we start to tame that chaos? And so with Pulumi, we really wanted end to end. It starts from build, you deploy it, but you're not done there. You want things like drift detection. You want things like the ability to go and search over your resources to find something when something goes wrong. We also have the same way GitHub tells you all the code changes that are happening and who made the changes and what the diffs were. You want to be able to do that for your infrastructure as well, both for just staying on top of the rhythm of the team, but also in the event that something goes wrong. And so for us, it doesn't stop with, okay, the infrastructure is up and running. Once you've got it up and running, now you need to version it and manage it and evolve it. And so that end-to-end life cycle is really important as well. That's part of cloud engineering. And honestly, that's where a lot of the infrastructure experts and a lot of the operations and sysadmins play a more significant role.
Yeah, importantly, also these days, people look more towards the governance part of it. So some people call it policy as code, compliance as code. Everything now is in code. So yeah, why is it important to have this governance and, policies in code as well?
Yeah, there's a phrase we like to use, which is secure by construction. You want to find issues before they go into production, right? And so policies code helps you enforce policies before you've actually done the deployment. Actually, it's part of the deployment. And honestly, for us, it begins even before that. Static type checking, the fact that you can run linters, if you want to use PyLint, you can use PyLint or ESLint, or you can encode your own policies into that. That's even before the policies code. So you really get these layers of defense to catch issues before they get out into production. We have customers that use policies code to enforce cost and budget concerns as well, to make sure, hey, if you're going to increase spend by more than 10% in a single deployment, you need to get approval for that, things of that nature. And so obviously, speaking to the managed part, it's end to end. You still want to find issues after the fact that have already gotten out into production, but ideally, you want to catch them before it's too late.
So you mentioned after the fact, it's like the drifts, right? Because sometimes, we deploy through the CI/CD pipeline, but some people who have access to the cloud, maybe they can just go in and change, or maybe you have access to the CLI, you also make some changes out of band. I think all these drifts tend to happen when you have multiple ways of changing the infrastructure. So I guess these kind of things really help. Speaking about infrastructure as code, you actually coined a new term called infrastructure as software. What is it about? What is the difference between code and software in this case?
We say infrastructure as code, but it's really been infrastructure as text until just recently. Actually, early in the use of the phrase infrastructure as code, it actually was more code than it is generally these days. Like we used Chef, and Chef had Ruby, and Ruby gave you cookbooks, and you actually could run tests. And there's a lot of benefits you had. At some point, we decided that infrastructure as code meant JSON, YAML, or domain-specific languages that were very limiting. And I think the idea that we needed to find something that differentiates what is different. Like it's not just the code, it's about the whole software engineering practice you have around that code. And so infrastructure as software to us is really just applying software engineering practices and treating infrastructure like it's software. you think about modules, you think about sharing and reuse, you think about how we architect these things. It's not about whipping out a piece of code to like script our way out of it. It's really about stepping back and thinking about this as building software. And I think that's the key difference.
You actually shared a very interesting evolution there, right? We all started with like Chef Puppet, where you write real code. For Chef, it's a Ruby code, it's a cookbook. And yeah, over the time, we kind of like moved. In my opinion, maybe it was also because the gap between the administrators, they have to learn new programming language, which maybe they were not taught so back then. And people have like struggles to actually learn programming languages. That's why people invented all these DSLs or maybe use YAML and JSON. And then over the time, we kind of like struggle as well with that approach and now bringing it back to the general purpose programming language. So I think that's a really interesting history of how all these tools coming together. There are now multiple flavors of infrastructure as code, as you mentioned, like more text configuration based, the JSON, the YAML, the DSLs, and also the code based things like Pulumi, CDK, Cloud Development Kit. Now HashiCorp also has it. There's another flavor, which I also found, which is the Kubernetes based. When I said Kubernetesify everything in the beginning, I'm referring to these tools where you manage or maybe provision infrastructure through Kubernetes. Things like Crossplane or maybe Kubernetes config connector from GCP. What do you think about this?
Yeah. And by the way, on the Ruby thing, sometimes people say, oh, well, with full-blown languages, you can create a messy code base. And let me tell you some of the messy code bases I've seen for CloudFormation and Terraform. And by the way, that same argument applies to application development. We don't go out there and tell people, oh, don't write Java because you're going to create a messy code base. We optimize for value. And that relates to the cross-plane answer. When I think of Pulumi, it's really three things. One, it's a programming model for how you express cloud architectures. That's one thing. Two, it's a deployment engine that can do infrastructure as code deployments. And the third is it's a cloud engineering platform that helps you accomplish everything we talked about earlier. You know, the CI/CD, testing, policy as code, the whole end to end. It's about how do you operationalize infrastructure as code. And I think of Crossplane as a very interesting alternative to that second thing. It's still all the YAML. So you still have the whole mess of the YAML. And it's not solving for any of the third things, which is all the software engineering, cloud engineering topics we talked to. So it's really just a deployment technology that can sit inside Kubernetes clusters and deploy to other clouds. And frankly, for folks that are all in on Kubernetes, that's it. You know, from now until the end of time, they're all in on Kubernetes. You know, I think Crossplane is a fine technology. What we see out in the world is almost all of our customers, if they're using Kubernetes, it's really what I mentioned earlier. It's not the center of the universe. It's really the scheduler for the cloud. As you pointed out, they're evolving in a bunch of different directions, like security model, things like that. But honestly, if I'm going to run in AWS, I'm probably going to want to optimize for the easiest way to adopt AWS. And just being entirely frank, seldom does that mean go all in on Kubernetes. But for some folks, it is going to be the right answer.
I find also maybe it's also a reaction to those system administrators or operations people who have Kubernetes background. All they know is like kubectl and you just manage through manifest, which is kind of like standardized in a way, right? You have the kind and then you have parameters. It's all standardized, same kind of flavors. You don't have like DSL, so to speak. Although it turns out some infra resources are complex and then you start having more annotations, more types and things like that. So it becomes quite complex as well. These are all exciting times actually for infrastructure and cloud. All these tools also coming in, bringing innovations. People now have a lot of options. What is the future in your view with all this cloud engineering?
Yeah, I think we're still really just getting started. For us, we are really excited about leading the innovation agenda for infrastructure as code and really showing the world that there's a new way of doing this. And you see, as you mentioned, CDK and now with HashiCorp, with Terraform CDK, like I think we've inspired kind of this new way of doing infrastructure as code. That's really exciting, but we still have a lot of work to do to make sure that Pulumi is the default option for everybody in the industry. But that's really just getting started. We just laid the foundation. We gave this nice programmable surface area on top of the cloud. You think of everything we talked about, cloud operating system. What is that missing application model for the cloud? How do we get to the world where the 3 or 5 boxes on the whiteboard are easy to express rather than decomposing into hundreds of building block services? There's a missing layer in between. And so I think for us, we're really focused on what is that next layer of abstraction on top of this foundation. And that will be much more for application developers who aren't necessarily focused on infrastructure as code. It really should be 10 times easier to build a modern cloud application. And so we're really excited about enabling that. And then honestly, Adopting cloud engineering is not push a button and we have cloud engineering, and it really, really should be. There's so many teams out there having to build their own custom platforms. And again, having the ability to extend the system, like with our automation API, is great. But would it be even better if you didn't have to start from scratch every single time in every single company? So I think that's the third major area, is really helping these organizations adopt cloud engineering at large scale.
So maybe if you can share us maybe some of the recent cool things being innovated from your customers using all these cloud engineering practices or Pulumi specifically. Maybe there are some great innovations that you can share.
Yeah, I think one of the best innovations is just like the productivity wins that come out of the box. And so the Bitbucket team at Atlassian, the team actually building Bitbucket, used Pulumi. They're able to introduce automation with test case unit testing in their favorite language. They tell us now they spend half as much time on all of the just like maintenance tasks related to deploying infrastructure. And that means 50% more time they can spend just on business customer value. And that's a pretty big deal. I'll look at another customer, Fauna DB, who's an earlier stage startup. They said, hey, it used to take us multiple weeks just to get a new feature shipped with all the infrastructure changes. And they've gotten it down to days and sometimes just hours. Again, they can just move a lot faster. I look at Mercedes-Benz. Similarly, they were able to just turn around and enable their developers to spin up microservice environments on their own. They used to have to file a ticket. This is all Kubernetes based, but now they can just use a Pulumi program, spin up their infrastructure. And because the central platform team gave them reusable components, they can say, give me a Kubernetes cluster on Azure, give me some data services, all these things. And a developer can just get an environment and now they're ready to go. And they can do that in minutes. Whereas previously they had to file tickets and wait for weeks to get those stood up. Those are just some examples, but commonality is scalability, but also just productivity and speed.
Very interesting use cases. So thanks for sharing that. So Joe, it's been a pleasant conversation. I learned a lot from the way of Pulumi works and cloud engineering specifically. As we move towards the end of our conversation, I have one last question that normally I ask for all my guests in my show, which is to share this thing I call 3 technical leadership wisdom. So think of it like advice that you want to give to the listeners here, maybe based on your experience, your expertise, or maybe some of hard lessons maybe.
Yeah, I think it's a great question. I love that question. I would say the first one is, when in doubt, just solve important problems for your customers and you really can't go wrong. I think it's easy to overthink things and build grandiose technologies, but ultimately your customers will keep you honest. If you just solve their problems, that's the easiest path to success. I think with Pulumi, we actually had our first paying customer before we even open sourced the thing, because we wanted to make sure that we're actually solving a problem that is important enough that somebody will pay for it. And I think throughout my career, I've often gotten interested in shiny objects and built things just for sheer pleasure. And that's fine sometimes too. But if you're starting a company, I think just solving customer problems is really the name of the game. Not just on day one, but also as you scale and grow as well. Like just listen to your customers and they'll tell you kind of what they need. So that's one. I think the second is good enough is never good enough. I think always relentlessly pursuing a higher bar, really compound interest, 1% better every single day compounds into something huge. In fact, 0.1% better every day compounds into something huge. And so I think it's easy to accept status quo. I think with Pulumi, when we started, we wanted to dream big and think of this amazing future that could exist. We're not going to get there by slowly iterating and just accepting the status quo. That leads to the third one, which is really dream big, but be realistic with what you can attain in a finite period of time. Sometimes say shoot for the stars and land on the moon. It's okay to make progress, provided you've still got that big dream that you're pursuing. If you're iterating and getting 1% better every day, then you'll probably get there eventually.
Wow, I find it really beautiful. Thanks for sharing that. I think it speaks a lot to those people who aspire big, dream big. Maybe they want to create companies as well. So Joe, thanks for being on the show. For people who would love to connect with you or maybe continue their conversation, asking about cloud engineering, Pulumi, and things like that, is there a place where they can find you online?
Absolutely. So I have a Twitter, Funk of Joe, FUNCOFJOE. I also have a blog, joeduffyblog.com, which I remiss in updating, but I will get back to it soon one day. But always just feel free to email me. I'm joe@pulumi.com. We've got a great community. I'm in our community Slack, so I'm sure you can find me if you want to.
Thanks again for being on the show. It's been a pleasant conversation. Good luck with all your Pulumi and cloud engineering things that you are doing. Thanks for that.
Likewise. Thanks for having me. Thanks, Henry.
Thank you for listening to this episode and for staying right until the end. If you highly enjoyed it, I would appreciate if you share it with your friends and colleagues who you think would also benefit from listening to this episode. And if you're new to the podcast, make sure to subscribe and leave me your valuable review and feedback. It helps me a lot in order to grow this podcast better. You can also find the full show notes of this conversation on the episode page at techleadjournal.dev website, including the full transcript, interesting quotes and links to the resources mentioned from the conversation. And lastly, make sure to subscribe to the show's mailing list on techleadjournal.dev to get notified for any future episodes. Stay tuned for the next Tech Lead Journal episode, and until then, goodbye.